Good morning, students. This semester, I handle electromagnetic theory subjects for your class, especially second year. Myself, Dr. P. Venkatesh Kumar. I am working as associate professor in Weltech Multitech Engineering College. So this semester, I handle for this electromagnetic theory subjects. In these subjects, okay, in this especially in second year fourth semester, you're studying for electromagnetic theory subjects. So in this subject, how much helping for you, especially each and every subject, they need for some knowledge you do for project and the application of this subject for what type of topics supported for some practical applications, especially in this subject, electromagnetic theory subject, especially supported for in machines. Okay, if you want to study for a AC generator and a DC generator, uh, in this generator, how the magnetic flux is developed in this flux, how much flux concentration is there. So based on that, we want to concentrate. Okay, so we want to calculate magnetic flux density, magnetic field intensity, and the electric field intensity and the electric flux intensity, flux density. So this way we want to concentrate this especially in electrical machines side. And if you come to power system, in power system, transmission line, how much electromagnetic effect is there in terms of inductance and the capacitance, how much effect is there, and a magnetic, if we come to transformer, how much mutually able to transfer magnetic flux. So that's way many things supported for this subject. Okay. Apart from that, biomedical engineering field, biomedical field, and physical signal processing and imaging field, computer chip designs we need for making of memory, and MEMS, wireless communications field, and designing of antenna, and electromagnetic interference, and steel technology, and if we designing of MRI scanner, machines, in biomedical MRI scanner, X-ray machines. That's places like we want to deal for electromagnetic subjects. So especially electromagnetic subject. Okay. So in this subject, what is the main objective? Now, what is the main objective of this course is the first objective is what means to analyze basic mathematical concept related to electromagnetic waves and vector fields, to impart knowledge on the concept of electrostatics, electric potential, energy density, and other applications, to understand concept of magnetostatics, magnetic flux density, scalar and vector potential, to impart knowledge on the concept of Faraday's law, induced EMF, and Maxwell's equation. So this is the main core subjective of this subject. In this subject, this course, especially the faculty point of view, we teach for these are the things. So based on that, our curriculum syllabus consists of 5 units. The unit 1 is vector analysis, unit 2 is electrostatistics, unit 3 is magnetostatistics, and the unit 4 is especially electrodynamic field, especially time varying magnetic, that's we simply will call, and the unit 5 is electromagnetic waves. So this is our major unit 5 unit content is there. In this elaborate I will tell. Okay, based on that, and mostly we try to buy these books. Otherwise, you download these books from net. Available Principle of Electromagnetic, Oxford University editions is very much supported. And apart from that, the Gangadhar also is good author for this paper. Okay, electromagnetic field theory. Especially very much we deal for problem and solve problem and tutorials. This very much supported Gangadhar and Matthews. And apart from that, a very reference book, standard book, William Haight is very good book for the understanding of electromagnetic field. So in this, I give some mind map concept. Okay, the unit 1, already we have 5 units. The unit 1 is vector analysis, unit 2 is electrostatistics, unit 3 is magnetostatistics, unit 4 is electrodynamic field, electromagnetic waves. So in this vector analysis, the mind map, first I give for some mind map. The mind map is speaking about what are the things, what are the content you studying for this semester, in this subject, in this course. Okay, in this course, what are the subjects you will study? So that's based, so the students able to refer the syllabus and able to making for this map means this very much supported. So especially vector analysis, in this vector, the first unit one vector analysis, in this vector analysis, what means a review of vector calculus, especially review of vector calculus, the coordinate system, spherical coordinate system or rectangle coordinate system. This way, so we can review of vector, what are things we'll do this vector analysis. The electrostatistics, in the electrostatistics, so you study for electric field intensity, electric potential, and dielectrics, and magnetostatistics, magnetic field, and magnetic force, magnetic materials, the electrodynamic field, magnetic circuits, Maxwell equation, transformer, and motional EMF. Next one for waves, the wave, how generate electromagnetic wave generation and what to calculate wave parameters. So this one, the mind maps clearly telling what are the things study in this course, especially in electromagnetic field theory course. So that's only this mind map. So this clearly understand what are things to study for this semester, these subjects. And in the first we start for unit 1. In unit 1, vector analysis. Okay, unit 1 vector analysis. So this is a unit 1. In unit 1, what are the topics? The scalar, vector, vector addition, subtraction, and multiplication, coordinate system, gradient, divergence, differential element, curl, divergence, and Stokes theorem, and divergence theorem, and electric field intensity, electric flux density, and Coulomb's law and Gauss law applications. Okay, so this is the first one. So this one I tell for vector analysis. In this only we tell for review of vector. So what we do for this step, and the coordinate system, with the help of coordinate system only we use for that and apply to our electric field system, especially electrostatistics. So what is a scalar? Scalar is here just for quantity. Simple say for magnitude. Scalar is a magnitude. The scalar simply represents only magnitude. So the scalar quantities are, scalar is a quantity. Just we tell for mass 10 kg, time 10 seconds, or temperature 10 degrees Celsius, electric charge, or DC voltage. These are the examples of scalar quantity. Vector means the vector is represent magnitude and direction. Example for our source having 10 volt moving to x direction or some angle. So which direction our voltages are moving, which direction our waves are moving. So the vector is nothing but magnitude and direction. The examples of vector quantities are displacement, force, velocity, electric field, and magnetic field. So this mostly we deal for in terms of vector quantity. So normally how represent in vector the coordinate axis. Example for I consider for a vector. The a vector, the entire circle. If you draw the circle having 360 degree. In this 360 degree, we want to represent three axes x, y, z axis. That's what we say for what with related to x, with related to y, with related to z. What coordination is there? So based on that, we represent x, y, z axis. X, y, z axis. In this x, y, and z axis. So I take for simple example. Let us take example for a vector. In this a vector, in this three orthogonal unit vectors, how to represent in terms of with respect to x-axis, ax. This is our quantity. This is our value. This is one directional vector, and ay quantity and ay representation, az representation. That's only here I represent next vector diagram. Ax vector, aa vector, az vector. So in this, the unit vector, how to solve? Okay, the unit vector. So normally we say for in this unit vector, a vector is equal to, so ax, how much this length, how much magnitude is ax, value, this example for 10 Newton or 10 volt. The moving direction is ax plus ay, how much? Ay into ay vector. This is a magnitude, and which direction is moving for this magnitude value. Okay, that's we represent vector Az into Az vector. So in this A vector, we want to calculate unit vector, which unit is represents. Okay, so that's only we will represent for here. A vector is determinant, modulus we say for model determinant. The determinant of A vector, how much overall determinant is there, overall value is there means. So this how to calculate means A vector is equal to determinant of A vector is equal to square root of Ax square plus Ay square, the magnitude of value of a x directional square plus y directional square and z directional square, Ax square plus Ay square plus Az square, Az square. So in this is only for determinant. Okay, we want to calculate how to calculate unit vector with the help of sorry. So with the help of the unit vector we represent. So that is unit. The unit with respect to A vector or B vector, which any W variables. Okay, the unit vector A we represent A is unit vector. How much unit vector? So the unit vector of A. This A vector, how much unit is there? The unit vector is equal to our normal vector A vector divided by determinant of A vector. A vector divided by determinant of A vector is equal to Ax vector plus Ay vector plus Az vector divided by square root of Ax square plus Ay square plus Az square. This way only if you giving any vector, be able to calculate using this concept, you can calculate this unit vector. So this unit vector is very much how much moving for our vector finally moving for which coordinate respect to these three coordinates. Okay, orthogonal coordinates, how to moving here. Okay, that's we can easy to identify unit vector. Next one is this general one. So next one vector addition. So if you adding two vectors, we get new vectors. We get for new one more vector. I am adding for A vector, B vector. So C vector is equal to A vector plus B vector. Okay, A vector plus B vector. So I'm getting for the new vector. This they were normal mathematically we say for C vector is equal to A vector plus B vector. But in a graphical representative used for parallelogram law. So with the help of parallelogram law, we represent A vector, B vector additions. So if you see here, in this vector, A vector, this is B vector, I will give it, okay, A vector and B vector. So the parallelogram law, this A vector, this is B vector. A vector and B vector. So in this parallelogram law means the parallel you draw the extend the line. Example for this is A vector, this B vector parallel, right? This A vector parallel, right? So the vector addition of we get for resultant vector, the new vector, resultant vector A vector plus B vector. That is new C vector. That is for our with the help of parallelogram law. So the vector addition, if one more question if you're asking means okay, please note down it. Parallelogram law. Okay, the parallelogram law is supporting for vector addition process. So from this we want to say some properties in terms of the vector addition. The vector addition is commutative. How say our vector addition is properties commutative means A vector plus B vector is equal to B vector plus A vector. So vector addition is associative. A vector plus B vector plus D vector, or A vector plus B vector plus D vector. There is a vector addition is associative, commutative and associative is obey. So if you're asking me, so 2 question, what are the properties of vector addition? Just note down it. Vector addition of this one. Okay, so this is the basic of vector addition. Next, I come to dot product and that is scalar product, vector product. Okay, so in our EMF, we used for two types of calculations, especially very basic calculations, scalar product and vector product. So first I give for two vectors, A vector and B vector, A vector and B vector. The A vector and B vector, the dot product will do means A dot B vector. That's what we say for that is scalar product or dot product. That is what is the meaning of the that means okay, the magnitude of A in this A, how much the magnitude of B's projections, how much the B also influencing here. So that's why we want to say dot, how much. I think we having two vectors, A vector and B vector. In this A vector, how much projection on A vector, how much here effect is there. That's why in a magnetic field we study. Okay, so already we have original field. Nearest one field is there. That is how much affecting. So based on A vector and projection of B vector. These two only we want to study here. That is for dot product. The magnitude of projection of B onto A. So that's what we say for A vector, that be AB cos t. That's how to say for, if we do for dot product, we get for what is scalar quantity, not vector quantity. The scalar product or dot product, the resultant output is scalar. Okay, and A dot B vector nature of A vector dot product of A vector dot B vector is equal to B vector dot A vector. That is a commutative vector, and also distributive law. Okay, this two is obey here for dot product. So based on that, I give for one more examples. In this vector, you see for that some A vector, we having two vectors, B vector and the C vector is there. So the addition of the already I told the parallelogram law is supported for making a vector addition. So based on parallelogram law, B vector plus C vector. So this effect, how much is there here? That's what the projection of B vector plus C vector onto A vector. How much is there? That's what you want to say for the scalar product. That is very much for how much effect is there, scalar product. And also additionally, we want to add some more point. If A vector and B vector are perpendicular, if perpendicular, I give the formula is what A vector dot B vector is equal to AB cos theta. So determinant of A, determinant of B into cos theta. So here theta is what? That is perpendicular is there means 90 degree. So theta is 90 degree. Anything, any magnitude is here is the traveling here, any magnitude is traveling here, but both vectors are with respect to 90 degree means the final output is what? 0 only. Net effect is 0 only if you perpendicular moving. That's what we want to hear. We want to remember it, note it. And next one, if A and B are parallel, so both are moving same directional, but same direction is same movement, but magnitude only different. So there is nothing difference is there. Nothing. There is no angle between A vector and B vector. That's why we represent 0 degree. So if this type of movement is there means both effect are multiplying. Okay, that is AB cos of, that's we say for unit vector. Next one, but this one wave or one vector is moving this direction, another vector is moving this directions. That is what minus AB as cos of 180 minus 1. But with respect to this value, so from this we want to note down. So if vector is moving same parallel means what? X Ax vector, that is the unit vector of Ax dot unit vector of Ax, unit vector of Ay dot unit vector of Ay, unit vector of Z dot unit vector of Az. Okay, that is one unity value. That's unit vector, unit value. If anything some changes is with respect to Y, with respect to Z means 0. This is a common law. Okay, Ax dot Ax vector is 1. This is one thing. This is for scalar product. Next I enter into vector product. In vector product, that's only for cross product. Vector product will say for cross product. Same similar way, X vector and Y vector and Z vector. 3 vector is there. X vector, Y vector and Z vector. 3 vector is there. Example for, so let us consider A vector and B vector. So this product of these two vectors is moving this direction perpendicular. Okay, perpendicular moving C vector. That's why here represent A vector cross product of B vector. Multiplication. A vector cross B vector. So what is the new vector? C. That is we say for magnitude of C is what? Both effect respect to sin theta. Actually we say for C is perpendicular to the plane formed by A and B. This is our plane. So this perpendicular X vector and Y vector is there. So form perpendicular plane. So what are the properties of this scalar product, commutative, distributed? But here in here. So A vector cross product of B vector is here. Final output is vector only, not scalar. Okay. And if A vector and B vector are perpendicular, so A vector and B vector are perpendicular means unity. So based on we want to write some properties with the help of that. So if A vector and B vector are parallel or anti-parallel, what happened? So if A vector is moving, this direction will just opposite of the scalar product. That is vector product we say for cross product. A vector and B vector both are is moving same direction or opposite direction means what? Sine of 0 or sine of 180. This way we prove it. Sine of 0 is sine of that is 0. The cross product is not completed. A cross B is out of the page, B cross A into the page. So that is what means. So our new vector is moving this direction or this direction. So based on if any interchange is there, that is only say for out of the page or into the page. So A cross B and B cross A is just reverse. So in terms of opposite directions, okay, negative direction. So just remember it, these things, and the AX vector, sorry, AX vector cross product of AX vector is 0, but in scalar AX dot AX vector is 1. Okay, just opposite of that, you remember it. That's why you say AX vector cross A vector is AZ vector, X vector and AZ vector is minus 1. That means X, Y, Z. That way you get. Okay, the X to Y, Y to Z. Okay, that's why moving means okay. The X and Y means next vector is moving direction. So that's why you tell for X, Y is there, next is Z. Here X and Z. What's meaning X to Y, Y to Z, Z to X only. But here we say X to Z is there, X to Z. That is what B cross A. That's what we put for minus of Y. And the same similar way, the unit vector of Y cross Y and the Z cross Z is 0. And the unit vector of Y and the unit vector of X is minus AZ. Unit vector of Y and the unit vector of Z is AX. And the unit vector of Z, unit vector of Y is minus AX. Okay, that's supposed to say Y Z. X, Y, Z. Y, Z, next moving direction is X direction. But here you see Z, Y, just reverse, opposite. So that's what we put for minus AX. This we just remember it and write note on that. So the cross product is not associative and but is distributive. So this way, just remember it. I will solve the problem later with that. I give one simple problems. This problem is covered for entire things. Okay, for entire vector analysis, some 70% of this problem is easy to understand. For vectors, I give for 3 vectors. For vectors, P vector, Q vector, and R vector given as P vector is equal to 2AY vector plus 4AZ vector, and Q vector is 2AX vector plus AY vector minus AZ vector, and R vector is equal to 2AX vector plus AY vector. Find P vector, the vector addition of P vector and Q vector. The subtraction of Q vector and R vector, determinant of Q vector, the unit vector of AR vector, dot product of that, angle between P and Q. So one by one we will solve. You see this. First, I write the given data first. P vector is equal to 2AY vector, 2AY vector, and 4AZ vectors. Q vector is equal to 2AX vector plus AY vector minus AZ vector. R vector is equal to 2AX vector plus AY vector. So apart from that, so first we want to calculate P vector plus Q. Only this 2 vector only we want to add. Here X is the AX, nothing is at 0. Here AX2 is there. That's will write for 2AX vector. Next to Y directional movement. 2AY vector and plus AY vector. So 3AY vector. Here Z directional movement is 4AZ. Here minus. So 4 minus 1, 3AZ vector. Okay, this is first subdivision is completed. Next subdivision is what means Q minus R vector. This is a Q vector and R vector. Here X is the 2AX minus of 2. So both are equal, so cancel. So AY here plus AY, here plus AY. Okay, minus of minus. I think here also 1, here also 1. 1 minus 1, 0. Next Z minus AZ. So minus AZ, here that thing is Z direction 0. So minus AZ is repeating. Okay, the second subdivision. And the third one, that's determinant of Q. This Q vector. Determinant of Q is what? The square root of 2 square, this vector. Value square. Here 1 square is there. Here minus 1 square is there. Magnitude value is 2 in the X directional. Magnitude value is 1 in Y directional. Magnitude value is minus 1 in Z direction. So, okay, square root of 2 square plus 1 square plus minus of 1 square. So, square root of 6. That is Q, determinant of Q. Next, we want to calculate unit vector. I told unit vector with respect to which vector? P vector, Q vector, R vector. But here only asking R vector. The unit vector of R is equal to R vector, determinant of R vector. The R vector is original vector 2ax vector plus ay vector. Determinant is what? Based on that 2 square plus 1 square. So here we said square root of 5. So 2 divided by 1 divided by root 5 into 2ax plus ay vector. That is unit vector. Okay, next the fourth subdivision is sorry 1, 2, 3, 4, and fifth subdivision is dot product. Dot product. That is scalar product. Q vector dot R vector. Our Q vector is 2ax plus ay plus minus az vector, and R is 2ax plus ay vector. So ax value and this value you want to multiply. Here ax is there. Here ax direct value is there. So 2 cross 2. Here 1 is there, here 1 is there, 1 cross 1. Here minus 1 is there, here nothing is 0. So minus 1 cross 0, 0. That's why I did it put. So the value is what? The scalar product come to scalar value. Okay, the dot product, u dot r. The next subdivision is the angle between P and Q vector. So the angle between P and P dot Q vector is equal to determinant of P and from Q cos theta. So from this cos theta is equal to determinant of P, determinant of Q divided by P dot normal vector P vector Q vector divided by determinant of P divided by determinant of Q vector. So 2ay vector plus 4az vector, that is our original P vector. Original Q vector is 2ax vector plus ay vector minus az vector. So determinant of P vector is 2 square plus 4 square. 2 square plus 4 square. Here is 2 square, 1 square minus of 1 square. Okay, cos theta is equal to. So from this, if we simplify that, okay, if you multiply here and here, what is coming, which dot product means, okay, P and Q vector, here x is there, here x is not there. So 0. Here y is there, here 2. Here 4 is there, my az is there, 2 minus 4. So minus 2. That's why here I put directly this way. So with respect to x, with respect to y, with respect to z, we multiply what the answer is coming here. With the subtract minus 2 is coming, and also down 2 square plus 4 square. So 20, here else 6. So 2 divided by this will cancel me. So here what 30 is coming. Okay, square root of 30. Angle, what is the theta is equal to cos of this 100 degree for 15.52 degree. Okay, this is our seventh subdivision, and next subdivision is our cross product. The cross product ax vector, that is our original directional moment. What is the magnitude of with respect to P vector, with respect to R vector next row. So that's why if you first fill it, ax vector, the unit vector of ax, unit vector of ay, the directional of az, the ps magnitude and the py magnitude and the pz magnitude, and the qx magnitude and the qy magnitude and the qz magnitude substitute here. So next we will minimize normal matrix material is ax vector 2 cross 0 0. So minus 4ax. That's how we show the answer. Minus 4ax. Here you see 2 cross 0 0 4. So minus 4ax. Here we remove 0 0 minus 8 minus of minus plus 8y. So here we will remove it 0 cross 1 0, 2 cross 4 minus into 2 cross 1 minus 4 AH. So P cross R vector. Next, the unit vector are normal to P vector and Q vector. The unit vector of this one. P dot Q already we calculate the unit vector of in terms of vector product. Okay, vector product. So P vector cross product of Q vector. So determinant of P, determinant of Q, sin theta, that is vector quantity. So that's what we want to represent. What is the unit normal vector? So from this an vector, the unit normal vector is equal to the cross product of P vector and the Q vector divided by the determinant of P, determinant of Q, sin theta. So this is for what? This is for the determinant of this one. Okay, thus we will substitute next step. P vector, Q vector is what means in terms of cross product. Already we calculated P vector cross and the Q vector. From this already calculated P cross and Q vector is determined is this one. We will substitute in unit normal vector. So unit normal vector is P cross Q is this one and divided by 2 root 9. So unit vector normal to PQ. So an vector is equal to, that is our normal vector, unit normal vector, we calculate. So the next final one. So in terms of dot product of first Q cross R, you know, and next we substitute this formula and verify it. So So remaining things we discuss in next class. Thank you.